Bonjour. Good morning. First of all, I'd like to thank the organization of the Design Modelling Symposium for selecting our research paper on a computational approach to landscape design. Before I start, I'd like to just highlight the approach word in the title. This is like a first iteration of hopefully longer research in time. And it was very important for us to be selected in this symposium, mainly for the topic that we're dealing with about humanizing digital reality. And this was precisely our goal in our research. And actually this picture represents the focus and the goal of our research, which is how digital and computational technologies can actually be applied, can be used for, say, like normal people in urban landscape context. So humanizing digital reality really fits what we were looking for. And what we're trying to do with this research was carrying out a mathematical model or a computational model for ecoregions in urban contexts. An ecoregion is just is a large piece of land with geographically distinct properties and qualities. And before I begin, a quick note about the authors. I'm just here representing this team of people based both in Shanghai, those three on the left-hand side, and myself in London. And I also like to mention the fact that this research has been carried out without any sort of academic or any other institution backup, let's say, which I'm not specifically happy about. So if anybody liked the research and would like to contribute in the future, I'm very happy to speak about that during the coffee break. So again, even though it's an independent research, we're open to any suggestions. All right, and again, the fact of being here in Versailles today really does take part of the discussions the whole research started with, and this European tradition of a highly geometrical landscape and landscape design, and its sort of relation or contraposition with a more experiential British landscape design, right, which is where I'm currently based. So we believe that actually computation can be part, or can, as an integration tool, can make like a connection in between this tradition of a highly intensive geometry-based design with a more experiential say central landscape design. In this case, I'm showing Kew Gardens in London, and with this tradition, we also focused as well, or we paid a lot of attention on the work of the pioneering work of Ian McHarg, who was a Scottish landscape architect, from which we borrowed his methodology of analyzing and the whole process that he used for landscape design in his pioneering book, Design with Nature, in which he kind of started this idea of ecological planning, and what we mainly borrowed was this what we called layer cake methodology, in which he divided or studied different topics of the landscape separately, let's say, and then overlaid that information into only one map, right? That this is the case. This is the case study of State and Island in the design with the nature book, and this is what we call the layer cake methodology, right? So by overlaying this information, we get final, say, analysis model. And this actually, this way of thinking, this approach, or this methodology was actually the beginning of GIS, computer software, and even I would say like CAD software in a way, right? This use of different layers of information that are overlaid together. And this is the approach that we used in our Shanghai case of study. And the reason why we use Shanghai is manifold. In the first place, it was because there is a 2040 plan, a master plan for the city of Shanghai, in which the government plans to create 2,000 green spaces in the city. So we believed there was a very interesting sort of point of interest. And secondly, because the regulations for using drones in China are currently very big. So it was very easy to fly a drone, whereas in the UK you need to have a license and so on. And even though the police in China might be less nicer than the UK, apparently it's easier to fly a drone without any license. So our research study was based in over there in Wannon Park, very close actually to where some of the researchers lived, in order to keep this sort of low expensive research. And the process, or the methodology that we carried out to sort of define the ecoregions was firstly to map the landscape, to map the park itself, and even though we here today have Chris, and we all use his work, and we take advantage of what he does, or what they do, which is fantastic and it's great. And we've used your tools, so so that's great. But we wanted to somehow kind of set aside all this sort of too easy to use plethora of big data, sort of climatic analysis, and sort of carried out more of a bespoke tool, right? Because sometimes architects were very lazy and use this in a maybe non-conscious way, right? So even though we have this capabilities, wanted to sort of provide or deliver a more of a again, more of a human-based and bespoke approach and study for this spark, right? Which is sort of this, and not much. This gives us a lot of information, but I reckon that the landscape that we wanted to work with was more like this. All right. So first of all, we use the drone mapping, the point cloud mapping, in order to get the both first 3D model and the contour lines for the park itself, and we integrated this 3D mesh in our very super basic conceptual 3D model. We didn't want to make anything specifically complex in this stage, and the fact that using this drone flight was really useful in order to understand three-dimensionally and the landscape that we were dealing with. Sorry. And secondly, we carried out more zero computation visual planting analysis, which is just going actually there and find out what planting species are there in order to produce this planting map. and then analyzing all those species according to an environmental tolerance that we mapped from 1 to 3 in terms of their resistance to shade, temperature, and flooding or drafts. And then, after this, we did carry out the environmental simulation with this data, both firstly, obviously, the solar analysis, both in winter and summer, and a very basic, again, wind simulation, super basic, just mapping the values between 1 and 3, whether they're low or high. And using also tools in Grasshopper to kind of simulate the water runoffs in the plot, which were important for the flooding analysis. And then what we did is, as Ian McHarg did like 40 years ago or more, this data overlay systematic approach in which we, those 3 parameters, sun, wind incidence, and water runoffs, were mapped, again, between 1 and 3 in both winter and summer conditions. And in order to get, firstly, plant's tolerance test, in order to verify or to check whether the current landscape design that we have in this park in particular, or maybe in general, in China and in other parts of the world, is really conscious against the species that they plant and how they plant it and where they do it. And again, overlaying both map tolerance test for sun, wind, and the water runoffs, we find that none of the plants, some of the plants were not properly or planted in the right way or in the right location. So we go from white to black. Whitish is more or less the plants that are in the right location, and grayish and black are the ones that are not. So these sort of train of thought and this process lead us to the final ecoregions modeling in the plot, both again for the summer condition and the winter conditions. And this gives us, this provides us a result that this kind of analysis or this kind of result has nothing to do with what there's currently in the park. So this is the ecoregions color legend, and those are the species and their intensity and tolerance toward those 3 parameters of sun, wind, and water that I discussed earlier. So again, the ecoregions map that we got, that this is our design proposal. So again, this is a tool for analysis, but also to propose a specific design for landscape, and how that rating for the sun, water, and wind would give us a specific planting or species for each kind of location, right? And whether they're tolerant to that microclimate or not. And finally, the computational tool can provide us specifically where those microclimatic sort of locations are, here and there. So as for the future applications of this, I was saying that this is a very first approach, mainly conceptual. Would like to explore the application and the use of drones, maybe with a more sophisticated device for mapping, say thermal cameras, in order to evaluate the health of the species, for instance. And we would also like to explore in depth the use of sensors on site, on outdoor space, and instead of having this grid of analysis, have a true kind of site-specific grid, not working with big data that maybe come from the airport kilometers away, but really use site-based data. And finally, would like to explore what I call some sort of environmental form finding, in which we could use form finding tools, not only for geometrical purposes, as we normally do, or we've seen here, but also to find some sort of connection between those ideas and those algorithms to kind of decide and design our urban landscapes and the species that we can actually design with in those. All right, merci beaucoup. Thank you so much.